Hey there, welcome back to the channel. Today we're diving into something truly groundbreaking, Google Project Astra. This cutting-edge AI system represents a massive leap forward in how artificial intelligence perceives and interacts with the physical world around us. If you've been following the rapid developments in AI lately, you're going to want to pay close attention to this one, because Project Astra is pushing boundaries in ways that feel straight out of science fiction. Let's explore what makes this technology so revolutionary and what it could mean for our future. Project Astra is Google's ambitious multimodal AI system designed to perceive and understand the physical world much like humans do. Announced in early 2024, it represents a significant advancement over previous AI models by combining visual understanding, spatial awareness, and natural language processing in ways we haven't seen before. Unlike many existing AI systems that excel at specific tasks but lack broader awareness, Project Astra is designed to develop a more human-like understanding of the physical environment and the objects within it. What makes Project Astra particularly special is how it integrates multiple forms of perception. The system can see the world through cameras, understand spatial relationships between objects, recognize physical properties like size and weight, and then communicate about what it perceives using natural language. This multimodal approach allows for a much richer understanding of the world than previous AI systems that often worked with just text, images, or video in isolation. The core innovation of Project Astra lies in its ability to build what researchers call a world model, an internal representation of how the physical world works. This includes understanding physics, object permanence, spatial relationships, and even being able to predict how objects might move or interact. Think about how humans naturally understand that if we see a ball rolling toward the edge of a table, it will fall off. These kinds of intuitive physical predictions are what Project Astra is being designed to make. In demonstrations, Project Astra has shown the ability to look at a scene and answer complex questions about it. For example, if shown a cluttered desk, it can identify objects, describe their relative positions, predict what would happen if someone bumped the desk, and even suggest how to reorganize the space more efficiently. This level of visual reasoning and spatial awareness is significantly beyond what most current AI systems can achieve. Another impressive aspect of Project Astra is its ability to understand and reason about changes in its environment over time. If an object is moved while the AI is observing, it can track that movement and maintain awareness of where things are, even if they're temporarily out of view. This object permanence is something that human infants develop as a critical cognitive milestone, and implementing it in AI systems has been a significant challenge that Project Astra is working to overcome. The applications for this technology are incredibly far-reaching. In robotics, an AI system with Astra's capabilities could revolutionize how machines navigate and interact with the physical world. Robots equipped with this technology could potentially perform complex tasks in unstructured environments, like homes, hospitals, or disaster areas, with much greater autonomy and effectiveness than current systems allow. For augmented reality applications, Project Astra could enable much more sophisticated and natural interactions between digital content and the physical world. Imagine AR glasses that truly understand the environment around you, recognizing objects, understanding spatial relationship, and intelligently placing digital content in physically appropriate ways. In accessibility technology, systems like Project Astra could provide unprecedented assistance to people with visual impairments by not just describing what's in front of them, but understanding the spatial layout and potential hazards in an environment. The AI could provide context-aware guidance that accounts for how objects relate to each other in three-dimensional space. For autonomous vehicles, the enhanced perception and prediction capabilities could improve safety by better understanding complex traffic scenarios and predicting the behavior of pedestrians, cyclists, and other vehicles with greater accuracy. The system's ability to build and maintain a consistent model of its surroundings, even as things change, is particularly valuable in dynamic environments like busy roads. Google has been careful to emphasize that Project Astra is still in the research and development phase. While the demonstrations have been impressive, there's still significant work to be done before this technology reaches its full potential or becomes widely available in commercial applications. The researchers are continuously working to improve the system's perception accuracy, reasoning capabilities, and overall robustness in complex real-world scenarios. One of the most intriguing aspects of Project Astra is how it represents a step toward more general artificial intelligence. While many current AI systems are highly specialized for specific tasks, Project Astra aims to develop more general capabilities that could potentially transfer across different domains and applications. The ability to perceive, reason about, and interact with the physical world is a fundamental aspect of human intelligence, and Project Astra is working to bring some of these capabilities to artificial systems. The technical foundation of Project Project Astra builds upon several breakthroughs in AI research from recent years. It leverages advanced computer vision models, combines them with large language models like those powering chatbots, and integrates specialized components for spatial reasoning and physics prediction. This integration of multiple AI approaches creates a system that's greater than the sum of its parts. The training methodology for Project Astra likely involves massive data sets of images, videos, and text descriptions of physical scenes, combined with sophisticated simulation environments where the AI can learn about physical interactions without requiring endless real-world examples. This combination of real data and simulated environments allows the system to develop a broad understanding of how the physical world functions. Of course, as with any advanced AI system, Project Astra raises important questions about privacy, security, and ethical deployment. An AI system that can perceive and understand the physical world with such sophistication needs careful consideration regarding when and how it's deployed. Google has acknowledged these concerns and stated that they're working to develop the technology responsibly with appropriate safeguards and limitations. The potential impact of Project Astra on various industries could be substantial. In manufacturing and logistics, robots with enhanced perception could automate more complex tasks than currently possible. In retail, systems could better understand product arrangements, customer behaviors, and optimize store layouts. In healthcare, assistive robots could become more capable caregivers by understanding patient needs and environmental contexts more thoroughly. For everyday consumers, the long-term implications might include more intelligent, smart home systems that truly understand the physical layout and state of your home, virtual assistants that can reference objects in your environment naturally, and augmented reality experiences that blend seamlessly with the physical world. Imagine asking your home assistant to find my keys and having it actually look around the room through cameras to locate them. Project Astra represents part of a broader trend in AI research toward developing systems with more human-like perception and reasoning capabilities. Similar projects are underway at other major tech companies and research institutions, though Google's scale and resources give them certain advantages in this highly complex and computationally intensive field. What distinguishes Project Astra from some other approaches is its emphasis on building a cohesive world model rather than just improving isolated perceptual tasks. Instead of just getting better at identifying objects in images, for example, Astra aims to understand those objects in context, their relationships to other objects, their physical properties, how they might move or be used, and so on. The development timeline for Project Astra remains somewhat unclear. Google has shown impressive demonstrations, but hasn't provided specific timelines for when the technology might be incorporated into commercial products or services. Given the complexity of the challenges involved, it's likely that we'll see gradual implementation across different applications, rather than a sudden, widespread release. For developers and researchers interested in similar capabilities, Google has released some related tools and APIs through its AI platforms, though the full capabilities demonstrated in Project Astra are not yet available as open development. This pattern follows Google's typical approach of gradually releasing aspects of its advanced research through various developer platforms after initial internal development and testing. The competitive landscape around AI perception systems is intensifying, with companies like Meta, Microsoft, and Amazon all working on their own approaches to giving AI systems better understanding of the physical world. This competition will likely accelerate progress in the field, potentially bringing capabilities like those demonstrated in Project Astra to market faster than would otherwise be possible. From a technical perspective, one of the most interesting aspects of Project Astra is how it handles uncertainty. The real world is messy, complex, and often ambiguous. Objects can be partially hidden, lighting conditions can obscure detail, and visual information alone isn't always sufficient to determine what something is or how it works. Project Astra appears to incorporate sophisticated methods for reasoning under uncertainty, expressing confidence levels in its perceptions and seeking additional information when needed. The energy and computational requirements for systems like Project Astra remain significant challenges. The sophisticated neural networks and reasoning systems that power these capabilities require substantial computing resources, which has implications for both the economic and environmental costs of deploying such systems at scale. Google and other companies are working on more efficient AI architectures, but this remains an important consideration in the evolution of these technologies. For casual observers of AI development, Project Astra might seem like just another incremental step in computer vision capabilities, but experts in the field recognize it as something more significant. The integration of visual perception, language understanding, and physical reasoning in a cohesive system represents an approach that more closely mirrors how human intelligence functions, where different cognitive capabilities work together rather than in isolation. Looking toward the future, the trajectory of technologies like Project Astra suggests that we may be moving toward AI systems that interact with the world in increasingly human-like ways. While we're still far from anything resembling general human intelligence, the ability to perceive and reason about the physical environment represents an important capability that many previous AI systems have lacked. In educational contexts, systems based on Project Astra's technology could transform how we interact with learning materials. Imagine a science education app that could look at a student's physical experiment setup, identify errors, and provide guidance. Or a language learning tool that could reference objects in the student's actual environment to teach vocabulary in context. For creative professionals, the technology could enable new forms of design tools that understand physical constraints and materials in more sophisticated ways. Architects, product designers, and visual artists could potentially communicate more naturally with AI assistants that understand spatial concepts and physical properties intuitively. One particularly fascinating direction for Project Astra involves how it might enhance human cognition rather than simply automating tasks. By providing us with insights about our physical environment that we might miss, systems like this could effectively extend our perceptual and cognitive abilities in meaningful ways. Imagine wearing glasses equipped with Astra-like technology that could alert you to potential hazards you didn't notice, help you find items you've misplaced, or provide real-time information about objects and environments around you based on a deep understanding of what you're looking at. The implications for scientific research are equally compelling. Project Astra's approach to understanding physical properties and spatial relationships could accelerate discoveries in fields ranging from materials, science, to biology. Scientists could potentially use systems with these capabilities to analyze complex physical structures, simulate interactions between different elements, and generate new hypotheses based on visual data combined with existing scientific knowledge. In the field of human-computer interaction, Project Astra represents a potential paradigm shift. Much of our current interaction with technology requires us to adapt to the machine's limitations, typing specific commands, navigating structured menus, or using specialized interfaces. With systems that can perceive and understand the world more like humans do, we move closer to interactions that feel natural from the human perspective, where the computer adapts to our way of perceiving and understanding rather than the other way around. The security implications of technology like Project Astra extend beyond privacy concerns. Systems with advanced perception capability could potentially detect security threats that humans might miss, from identifying suspicious behavior patterns in public spaces to detecting tampering with physical infrastructure. At the same time, such capabilities in the wrong hands could enable more sophisticated surveillance or security breaches, highlighting the importance of developing these technologies with strong ethical frameworks and security protections built in from the ground up. For businesses looking to prepare for the impact of technologies like Project Astra, there are both challenges and opportunities. Companies will need to consider how advanced perception AI might transform their operations, customer experiences, and competitive landscape. From retail environments that adapt to customer behavior in real time, to manufacturing processes that incorporate machines with human-like perception capabilities, the potential for business transformation is significant. Organizations that begin exploring these possibilities now may gain advantages as the technology matures and becomes more widely available. The ethical frameworks governing the development and deployment of technologies like Project Astra are still evolving. Questions about consent, privacy, bias, and accountability become increasingly complex when AI systems can perceive and understand the physical world in such sophisticated ways. Who owns the data about physical spaces that these systems collect? How do we ensure fairness in how these systems interpret and respond to different environments and individuals? What responsibilities do developers have to mitigate potential harms while maximizing benefits? These questions will require ongoing dialogue between technologists, ethicists, policymakers, and the broader public. In summary, Google's Project Astra represents a significant advancement in AI's ability to perceive and understand the physical world. By combining visual perception, spatial awareness, physical reasoning, and natural language capability, it's pushing the boundaries of what artificial intelligence can do and how it can interact with humans and the environment. While still in development, the potential applications span robotics, augmented reality, accessibility, autonomous vehicles, and many other fields. The path from today's demonstrations to widespread practical applications will certainly involve numerous technical challenges, careful consideration of ethical implications, and ongoing research. But the direction is clear. AI systems are developing increasingly sophisticated ways of perceiving and understanding the world around them, and Project Astra stands at the forefront of this exciting frontier. As we continue to follow developments in this space, it's worth considering both the remarkable opportunities these technologies present and the responsibility we have to ensure they're developed and deployed in ways that benefit humanity. Project Astra and similar technologies have the potential to make our interactions with AI more natural and intuitive, but they also raise important questions about privacy, security, and the changing relationship between humans and increasingly perceptive machines. If you found this deep dive into Project Astra interesting, please hit the like button and subscribe to stay updated on the latest developments in AI and technology. Drop a comment below with your thoughts on how you think technology like this might impact your field or daily life in the coming year. Thanks for watching, and I'll see you in the next video.